All right, sorry about that. We had a little audio difficulty. Fortunately, we've got a room full of talent here, and we figured it out. So this is the Desert Blockchain Monthly Meetup, and tonight we're going to be talking about IPFS, and also we've got IPFS loaded on some small board computers, and we're going to be talking about the upcoming Desert Blockchain day-long event, which is going to be on Saturday, April the 30th, 2016, here at Gangplank Chandler. So thanks for tuning in. If you are interested in joining the Hangout, you can email me, although I'm not going to be following the email that much, or you can call me at 602-228-4486, and we'll try to patch you in. So it looks like we got some viewers on, and let's just kind of go around the room and say what your interest is tonight and what you guys like to go over. You want to start? So start. Maximo?
I'll start. My name is Maximo. This is my first time in this meetup, and I was invited by Jay a while ago, so I'm happy to be here, and I'm just here to check it out and see what you guys do. Awesome.
Maximo runs the version control group and does a great job with that and teaches us all how to use GitHub and all sorts of other interesting things. Which, by the way, what we're dealing with, and Elio's gonna, he's the expert in that area. But since Christian's not here, I'll take this is an expert role. This is very much akin to Git and uses some of the same paradigms as Git. Right?
Yeah, these are both Merkle tree or Merkle bag systems. So we'll dive into that a little bit more. But first, so go ahead.
My name is Mike. This is the first time I've been to the Desert Blockchain. I'm not a programmer, computer literate guy. I'm interested in the philosophical perspective of decentralized systems. And so I wanted to learn more about the blockchain as it relates to Ethereum and other decentralized possibilities, something along that line.
Cool. And I'd like to say about the Ethereum, for those of you that might not be following Ethereum, it's quite a story because they've gone from a market capitalization of 0 to approximately $1 billion in less than a year. So if you're interested in blockchain, distributed ledger, decentralized technologies, cryptocurrency, check out Ethereum. I'm not necessarily endorsing them, but it is quite a story. And they've also, one of their applications is in the Internet of Things and also identity management. So topics that we're very, very interested in here. So go ahead, John.
John Tracy. My background is networks, Cisco CCIE. I've been at QSA, so I've dealt with encryption and PCI stuff quite a bit. I just was at RSA and doing the crypto track, unbelievable. So yeah, I'm going for a master's in computer science, going back for graduate. I'm taking calculus for the first time, and I'm easily 20 years older than everybody else in the class. That's pretty scary. But this is, for me, is I'm out of operational stuff. And they understand about block ciphers, and that seems to be where financial services is going. A lot of financial services. And the whole key, though, is still PKI, the whole asymmetric stuff. There's a lot of opinions about why it may be better for transactional. That's still to be determined. Hence, then users group like, we're using it for specific things, but we're seeing some latency and it's not working as we hope. That kind of stuff. Cool. Other than that, I appreciate all the effort putting this together, and it's a timely subject. Thank you.
Awesome.
I'm Bill Maher. I have a little company called Special Computing, and we do embedded boards. And I'm very interested in creating all these devices just to understand how much processing power and what we can do, so that we don't have a lot of compute power yet. And what I'm concerned with is that there's all these features that come out, but you can't implement it unless you have this new hardware that comes on. So I want to know what can we do and separate the architecture from the marketing, I suppose. to see what can be done. And there's a lot of useful things that don't require the whole, package to be installed, so you can demonstrate all these stupid features that maybe may not need. So generally, if the arc of the development of this process, I imagine that we can do a lot of useful things before the entire system gets figured out. So that's what I would like to do, is create a whole bunch of really simple, stupid little things, and if it's stupid enough, you can explain what each of them can do.
I mean, let's be honest, that's how most of today's computer systems were built.
Yeah.
Was half-ass at best, and then adding pieces on, which there's some merit to that, to not pre-optimizing, building as you see need. And I've heard that referred to a number of different terms, but one is pain-based programming, where you just do something manually until it becomes too painful to do that manually, and then you write code to address that pain and make it go away. So if you have to manually look through a list of 1 million users, or let's say a phone book, for instance, if it starts small, it's 100 people, then there's no sense in writing code to search for 100 people's names. It's done by a human pretty easily. Once you start getting into thousands, tens of thousands, millions, etc., then even just hiring people to coordinate that doesn't work, so then you write some code. And now you can search through billions of records trivially. So anyway, that's
But that's the scaling part. But
So
I'm
before we get into all that,
I'm sorry, go
Ilya,
ahead.
go ahead and,
Go ahead.
So I'm Ilya Grieko. I'm involved in a number of things around town. I chair one of the subcommittees on Security Canyon. I have several talks coming up. We have a panel coming up. I haven't got the dates back for that, or I announce it right here. But Mobile Mondays is an awesome security meetup put on by the ladies with Cell Trust. And so we're going to do a panel discussion about a lot of these same ideas. And hopefully we'll have some stuff ready to do live demos even by that point. I work with a lot of educational stuff too, so I like seeing some people who aren't in their teens, because I think that's a huge problem in computer science, is ageism. And the thing that really drives me nuts is watching the entire industry reinvent the same stuff we had 20, 30, 40 years ago. Same stuff, works a little bit worse, doesn't have the entire idea fleshed out, but hey, we built it in JavaScript, or hey, we rebuilt it in Python, or Ruby, or Java. Great, we had that. Let's stop wasting time reinventing the same stuff a little worse, and let's start moving forward again. Dying for that to happen. It's not happening yet. I'm hoping within 10 years we can start making forward progress again. Well, I shouldn't say that as a blanket statement. There is some cool stuff happening. Some of the stuff we're going to be talking about tonight, Ethereum, IPFS, Nebula, Freenet. There's a lot of stuff out there that actually is pushing the boundaries of what we can do in computing. Just not enough for my taste.
So you don't think it's cool enough to implement a 8086 emulator on JavaScript? That's not
it's pretty cool. It's pretty cool.
Guys, so this falls under the, there was a great Ruby AZ talk a year or two ago, actually maybe 3, anyway, it was about how to do weak motion programming, which is like a little finger connect that goes in front of your computer, and the conclusion of that talk, they showed off all kinds of fun stuff you can do. It's really cool, but no one could think of an actual use for it that would make computing better in any meaningful way. Like, cool, I can go like this, and I can move a window from the left to the right side of the screen. Yeah, but I can do that with my mouse, or I can do that with a keystroke. And those are actually faster and easier to do.
Yeah, but you can do it like Tom Cruise does.
I know. So there's a coolness factor which may or may not correlate to a usefulness factor. And that's the focus of a lot of stuff I'm trying to do.
Solution looking for
let's build stuff that's useful, and then it's easy to throw cool stuff on top of useful stuff. But if you build cool stuff, you can't always make it useful just because it's cool.
But you can get funding.
So you can get funding. You can definitely get funding if it's cool.
Yeah.
And you can end up costing everyone a lot of time. It's making whole new business areas.
So just to, add to what Ilya was talking about, he has a project called Nebula, which is a web of trust architecture, right?
There's 3 main parts, and we can look at the draft. I've actually added a lot more, and I'm ready to start circulating draft version 2 for comments. Since you're on there, Jay, and a few other people, and actually anyone wants to take a look, you're welcome to. I'll add you guys to the repo. I'll probably make it a public repo shortly, but right now I haven't done that. So we are seeking funding. There's some IDIQ money in town locally for defense-related projects. This would tie in with initiatives that are from the federal government to ensure that the people of Arizona and actually the rest of the country as well have reliable communications. So if there were a natural disaster, a terrorist attack, anything like that, there's 16 key areas they look at, communication being one of them. And we saw this in New York with the Sandy Hook hurricane, or excuse me, with the Hurricane Sandy in Red Hook. It knocked out all of the traditional communication systems. There was no phone, there was no internet, it was nothing. And there was a group, the Red Hook Initiative, that put together a mesh network. So IP networking, just with little battery-powered nodes, and they actually restored IP networking weeks before the phone companies could get their systems back up and running. And so those people were able to call home and send text and Skype and email and tell their loved ones, yeah, we're fine, don't worry about it. The house has some problems, but we survived, everything's mostly okay. So that's something I think we should be able to have communication you can trust, communication that you can rely on. If you put data in the system, you know it's going to be there now and 10, 20, 100 years from now. And communication that's reliable, that doesn't just drop out because one single wire got snipped. And there have been some great examples. I don't know any of the specifics right now. I have to look it back up. But locally in Flagstaff, there was some vandalism. I think that was last year. Some jerk with a shovel cut a fiber optic line and severely degraded all of Flagstaff's internet connectivity.
10 years ago, someone with a backhoe just saw it across the ground, cut out Tucson.
Yeah,
That's what I classify as a disaster, because then I can't watch the cute kitty videos. It's
The horror.
It's a horror. Yeah, it's a nightmare. I'd like to cover a little bit about what we got on the table, and then we can kind of open it up to conversation, because some people watching this and the recording, whatever, are kind of interested, might be interested in what was advertised here. So we have taken a decentralized platform for content, basically content management. Correct me if I'm wrong on any of this description, but if you look through some of the Desert Blockchain videos, we've spent quite a bit of time on something called IPFS, which is an interplanetary file system, which is basically taking content, whatever the data is, breaking it into chunks, hashing that content so that it's secure, and then chaining those hashes or those blobs together using something called a Merkle DAG, which opens up a whole new world of content management, connectivity, security, and so forth.
Now, before we go on, first of all, does everyone know what a Merkle DAG is?
Okay.
Roughly.
Okay,
But
yeah, go ahead.
is the Merkle DAG what makes it different from storage? I don't know if storage, what they use or not, but what
So,
you're describing sounds very
There
similar
are
to
a
storage.
lot. Merkle DAG is an old idea. I think the patent expired, I forget how many years ago, but it was patented. It's no longer patented. I think it was Ralph Merkle, if I remember right, was the guy who came up with the idea. And the original idea was called the Merkle tree. And the idea is if you take a cryptographic checksum, if you have a big hard disk, and back then big was not a terabyte, but today terabyte's not big. If you have a terabyte of data, and I want to know, is the stuff on this terabyte the same as all the stuff in this terabyte of whatever storage media? Well, to diff the entire thing, to go through 1 trillion bytes, takes a while.
This is how they're eliminating the need
So-
to download the entire blockchain.
Yeah, so the idea is,
Yeah, hash.
if you take every file or every block or however you want to divide it up, and you checksum that with a cryptographic checksum, MD5, SHA1, SHA256, whatever one you want to choose, doesn't really matter which you use, just for the concept anyway. If you take that and you checksum that, and you take that whole level, that entire directory, folder, whatever you want to call it, again, it's sorts of different structures, and you checksum that. So you take a list of all the checksums and checksum the list of checksums. And then you go up another level and get all the list of the checksums and checksum those checksums. You can do this all the way up, and at the very top, you'll end up with a root checksum. And that root checksum, then if both are the same, then that's all you have to check. You have to just compare those two little bitty checksums, which is blazing fast. And if they're not the same, then you can descend the tree as necessary, and you're still, worst case, unless everything is different, you're only having to compare parts of a tree. You're not having to compare all bits and bytes on an entire piece of storage. So that's the basic idea of a Merkle tree. A Merkle DAG generalizes that idea. It's a directed acyclic graph, which is basically a tree. All trees are DAGs, but I don't think all DAGs are trees. So a DAG allows several different things to point to the same object, whereas a tree, not as much. And this is how IPFS operates. It's a DHT, or distributed hash table. So it has an algorithm that's based off Cadmelia coral and a few other little magic bits of goodness sprinkled together, and it visualizes all the computers on kind of a line. You can think of this big line, like a linear from the first address from 0.0.0.0. Actually, that one's not legal to use, but something along those lines, up to 255, 255, 255, 255. So you can think of that as a line. And then you can wrap it around with modulo, so it now forms a ring. And it's this way of distributing stuff throughout that ring. So if you look at any random, you know about where you need to look in the ring. And if you look at the wrong spot, you can know exactly how many hops it's going to take logarithmically to find what you need. Whether that means you just looked in the wrong spot, or that node is offline, or that data got moved or deleted. And it has provisions for redundancy and all this. So we're basically sharing this huge ring of nodes that all contribute to the shared data pool across the entire planet. And in theory, once we finally leave this planet someday, then it could be interplanetary. There's enough space in here where we could store all of humanity's data for probably millennia to come. And it's all this, it's almost like a magician's hat. You jam data in, it gets added into the Merkle DAG and then distributed throughout the DHT. And then anyone who wants it, all you got to do is say, here's the name of the data. So this is why we call it a named data or content addressable. You say, here's the hash of the thing that I want. And it's able to find that. And whether that thing is just one blob, just like a picture, a video, whatever it is, or it's a directory full of a whole bunch of other stuff that has all these folders and nodes under those and such. Either way it works. So it's a really nice way, and that's about as complicated as IPFS gets. It doesn't add any kind of ownership. Well, it adds a very light layer of ownership semantics and data, durability and such on top of that. But it's mostly a transport layer. But it's a really, really solid base to build really interesting things on top of. And it's actually gaining a fair amount of adoption because there's been a ton of projects that are very similar. In fact, the first one that comes to mind, I don't think it is.
Before we get into that, let's just kind of summarize it, and thank you, Leo. I'd like to make 3 points for why we're interested in IPFS, interplanetary file system. Why do we care about this? Well, number one, I think it opens up a whole new level of security. So because everything is cryptographically hashed and secured, there's a public-private key and all that stuff. This is a whole new realm of security. I think the other thing that's interesting is, would you add anything else to that?
I don't know if I'd use security potentially, but data integrity and assurance.
Okay.
So what it gives you is, if I ask for that data right now, and I'll try to keep this real short. Right now, there's this stupid chain of assumptions we make. When I go to a website, when I go to whatever.apple.com or apple.com / whatever the path is, I'm making a number of assumptions. First off, the domain name is useless to me. In order to actually talk to that computer, I need to have an IP address. So the first thing is I got to do a DNS lookup. And then once that, if that goes well, if the DNS hasn't been poisoned, if I'm actually talking to legitimate DNS servers, then once I have that IP address, then I do a whole TLS negotiation where we're relying on the CA system. Jay gave an excellent talk at ISSA last year about the problems with the CA model. And actually the guy before you covered some legal implications, which was awesome, and together really well. So that whole model has been broken. All you need to know about that is, if I told you—
By CA, we're talking about certificate authorities.
Yeah. So in a nutshell, that model is, we're going to pay companies to be trusted. That doesn't immediately sound like the dumbest idea ever. I don't think you fully understand trust and how that works. So that's broken. That's been compromised in like really serious ways numerous times already over the last several years. And then once all that, assuming we're talking the right IP, assuming the key we're getting back is valid, we're still also making the assumption that someone on behalf of that organization that owns all that put the data that I'm looking for at that path on that server. But we have no way to verify that. We're just assuming that it's right. Whereas with IPFS, as Jay was saying, because it's a checksum, I'm saying, here's what I want. I'm not saying, here's the machine I want to talk to, and here's where I want to look. I'm saying, here's what I want. And so it's kind of like the difference between just picking up, just going to someone saying, here, the stuff is in this locker. It's at this address. Go pick up whatever they give you at this address. And you go, and hopefully they give you something good, versus going to a library or a bookstore saying, here is the ISBN of the book I want. And I can get that book from a lot of different bookstores and a lot of different libraries, but this number identifies that this is the book I want. So I don't really care who gives me the book, as long as they give me the right book.
And it's immutable.
Yeah.
Yeah.
That's the other thing.
So there's a whole realm of security around IPFS, but the other thing is that it's could be the whole next internet. So basically, the way this has been created, it's certainly backward compatible to what we've had, but when you go backward compatible, you start to get into some of the issues that Elio just talked about. But the whole paradigm around what we've been accustomed to in terms of the internet might be disrupted via IPFS, and so there might be a whole new realm of connectivity. So security, a whole new realm of connectivity that's sort of like the next evolution of the internet, what we're accustomed to. And the other thing is it's completely decentralized. So you, as an owner of the content, start to have a much, much greater level of control. And basically, he doesn't want to call it ownership, but I would call it control and ownership of your content. So, anyway, so those are like the three, I would say just three of the elements that why we're interested in this IPFS. So in addition to that, what we've done here, what we got on the table, and you can't see it, but we have actually successfully this afternoon loaded IPFS on this Intel Edison board, which is
That's pretty cool. That's a tiny little guy.
Sure what the
Yeah.
What's that?
I don't know if they can even.
So
see
this is a tiny. It's about the size of a book of matches, maybe a little bit smaller.
It would fit.
Yeah, we're gonna put a link on the thing for that.
Yeah. So this is an Intel Edison board, and we've successfully loaded IPFS on it today with the help of Stuart Christie of Intel. This is a Raspberry Pi 3. This also contains IPFS, and this is a Raspberry Pi 2, which also contains IPFS. So we're interested in experimenting with this decentralized content management, cryptographically secured platform on small board computers and microprocessors to start to not only contain content and create this swarm of nodes using these small board computers, but also to start to tie these things together, because part of what we're going to be doing in the next, I don't know, month or two, 3 months, is you can take IPFS and you can actually build a blockchain associated with it. So there's not a blockchain associated with IPFS natively, but you can create a blockchain.
So, well, I guess let's throw that in there, since I don't think we recorded the last few times we touched on this, but the same way that a square is a subset of a rectangle, it's a rectangle with constraints. That's how blockchains are to Merkle bags and IPFS and Git and all those. The blockchain is a Merkle bag where you say, we do not want forking. We either prohibit it or we do everything we can to minimize forking. So whereas in like Git, you can have a whole bunch of branches and you can merge them together and leave them hanging and do all kinds of crazy stuff. Blockchains say, nope, nope, no branches. And if you get a branch somehow, you have all these strategies to try to put it back together or throw one half away. And we never
Branching,
want
but no
branch.
forking. You can have branches, but you can't have forks.
How are those different? And
Well, before we dive into that, so anyway,
Oh, sorry.
was that your point?
that was the main thing. Is just
Okay.
knowing that you could. IPFS is very amenable to building blockchains within it.
Yes, exactly. Yeah. And so, okay, Maximum.
So you said that you've loaded IPFS into this microcomputers,
Small board computers.
small board computers. Does that mean that IPFS is a software or?
Yes.
Mhm.
Yeah, just
Yeah, it's written. The reference implementation is written in Go, which is good or bad, but the performance is not bad. There are two other implementations. There's one they're trying to do in JavaScript that's not as far along, but it's coming along. And there's another one, is it Python, I think?
Yeah.
That's still, although the Python one is not anywhere near feature parity with the Go implementation. It's a lot further behind so far.
Yeah, and then on top of the hardware that you see here, it's also implemented on a container, a Docker container. So you can just grab it, do it all online without actually having the physical hardware.
Yes.
Trying to absorb more big picture.
Yeah.
When you talk about Go, I just read about Go with
Yeah.
reference to Ethereum. Is the draw to Go? What I thought my understanding is it allows you to to accomplish what you want with less bytes, because they're using it right for writing code into the contracts so that they can make them do what they want with less bytes, I thought, because
Go is actually more verbose.
is it? Okay.
Go is on the opposite end of Haskell and Ruby and all those. People complain that Haskell's, you can do too much, you can go too nuts, and when you pull down a new module, you have to figure out first how to use the module because they can behave totally differently. And so Go is more on the Python side of things, where Go won't even let you override basic operators.
Well, I might be wrong.
I think the reason they're using Go.
Are they using it for the transaction contracts, or is that just for the?
I'm not
backbone?
quite sure with Ethereum exactly which parts, but I know Go is a key part of their platform. But it's my understanding they're using Go instead of JavaScript because it has more of a structure to it.
Okay.
So if you want to,
Well, it is.
Yeah.
It's. I don't know if I'd say
more restricted.
it's
It's a more restricted
faster
language.
than JavaScript.
It's faster and it's more restricted language than JavaScript. So they're
And the VM, don't forget the VM.
they're virtual machine. But when you're looking at the guy who's trying to write the proof of stake versus proof of work is actually doing it in Scala. So
Scala is like Haskell's evil twin. That's something
Yeah,
not quite
So-
right with it.
but I think their
Yeah, she works at a big company.
their motivation there is they're gravitating to languages that are more structured, that are typed languages, because they want to be able to prove things as much as possible.
Okay.
So if there was more leeway, like with JavaScript, it's harder to keep your developers on the same page, and B, it's also
JavaScript's a Charlie Fox.
So JavaScript is wonderful because it's so it's the language of the web, but if you're trying to prove things, if you're trying to keep a team on the same page, that's theoretically easier to do with things like Go.
I
Does that make
appreciate it. I
sense?
didn't mean to take
No,
that.
that's cool.
No, I mean that's why Go was invented, was to aid maintainability.
Yeah.
And say, look, you can only abstract up this high, and then you have to make everything explicit, which is good and bad.
Yeah.
Which for maintainability is a win, because you're not going to hide functionality in like a monkey patch or an extension that does weird stuff. But it also means you're writing more code, and this is my thing that I've been arguing with a lot of computer science people about, but every study that I've seen says that there is a minimum number of external bugs per kloc. So that's how many bugs make it, not when you're just playing and testing and writing code, but how many bugs make it past you and all your tests and your type system and everything else, and make it out to the outside world per 1,000 lines of code you write. And for really good programmers, you're looking at 5 to 7 external bugs per kloc. So the more code you write, the buggier your software is going to be.
Well,
And we haven't found a way around it.
well, and we just this week had a shining example of that, where we got the most valuable company on the face of the earth that was basically saying to everybody, all their users, hey, this is secure. The FBI wants to crack into this, and we're not going to let them crack into it. Well, guess what? Somebody knew how to crack into this, and Apple does not.
And that probably wasn't the only way. So
And that kind of ties into the IPFS. You guys are just getting introduced to this, but we think that IPFS offers a way to, because of the hashing, because of the cryptography behind it. I mean, this is a very, very compelling way to secure content, I think.
definitely. And again, it's not the first in. You look at Freenet Project, Publius before it. There's been a whole bunch. Actually, Napster and Nutella were some early movers. Nutella was fully decentralized. Napster was not. It was mostly decentralized, but with central coordinating
Then you got
servers.
BitTorrent.
Yeah, BitTorrent, but that's closed source, so I kind of write that off. It's good stuff, but anything that's closed source is not worth. It's not worth building on top of, because if that company goes under and changes its mind or anything like that, then you can't build the next internet on anything closed source. That would be a terrible idea.
So companies try.
What other questions do you guys have at this point?
Well, IPSF, I'm the network architect, and I'm real familiar. This is Novell. You're talking Novell from 1985, because I'm a CCNE.
Yeah.
That's got to be what it is. This is a network thing. So this is all like DARPANET, like when Moses was pup and taking the next step. Because all of these hashes have to be routable. So they're all layer 4 stuff. So bottom line is, because I built internets and I've been forever, and then you're going to be able to route this stuff. So I know it's decentralized, but still, routing tables related to where you're going to find the hashtag or the IP address. This even could be a layer 2. There's a whole thing in networking right now about software-defined networking, like big switch stuff.
Yeah.
It's all layer 2. They're kidding you thinking it's layer 3. It's all layer 2. It's all spanning tree that I did a billion years ago, but it's really fast. And it's with faces of the darknet. A lot of the core and that stuff is based on software-defined network.
IPFS is not that. IPFS is that, but it acts as an overlay network. I believe UDP. But there are 5 government initiatives, my favorite one being namedata.net, which is exactly what you're talking about, of ripping out TCP/IP, maybe keeping the IP part of it, but tossing everything else and building a brand new protocol that would do what IPFS does at the network level.
But layer 3 stuff. But even if it's layer 4, still you've got to be able to route it. So you're talking about how am I going to define what the content is? So I have to have tables. I got to have an ARP table. I got to have an IP table. I got to have a BGP table. So that's only, but it's way cool. I first time I've heard of
Are
it.
you familiar with the flood search routing, like in the military phone systems?
I've done some stuff a little bit with General Dynamics and that and cool stuff. But I'm traditional IP stuff like Novell. Very cool, very cool. But the question still comes down to, we talk about it offline, I don't have to, is I've never heard of that. So it's very cool, but what you're routing is you're routing the hashes. And so still comes down to that Bitcoin is the blockchain, block cipher is still PKI. So
Wait a minute. Blockchain and block cipher are 2 different things.
traditionally it's called block cipher, chain. But
there's a whole. I think what you're talking about, John. I think what you're talking about is what is the naming, addressing, and numbering associated with this, so you can do the lookups and the.
We can talk about that offline. That's not really relevant. Relevant really is the block cipher or blockchain, and no problem with that. It's still. I hadn't thought about that. Being able to do it from a network layer or from a transport layer.
Just keep in mind that IPFS also includes the data naming server.
So it's like your packet's got, or if it's a packet, how you want to call it, you've got a header that's not just the IP address. You've got a lot of fields within that header that you can customize
And
accordingly.
then, like for instance, it has a text area, so you can actually have a human readable of the tag. It's no longer a tag; it's really a content hash.
Yeah, and I see this also as this is the 3rd revolution in human telecommunication. We had circuit switch networking, which was great. It was the telegraph and later the telephone. And then we had packet switch, which we're still, I'd say we're halfway into packet switch. Because the way most people have deployed packet switch networks have actually been with circuit switch topologies and technologies.
There are two switches, still well over the place.
Yeah, so we're not really taking full advantage of packet switch.
Pipes.
And
Modem.
yeah, you know, it's easier multiplexing. That's all it is at this point.
Yeah.
But main data is totally different because now you're not saying I want a connection to this, because everything till now has said this machine wants to talk to that machine. This computer is basically calling up that computer. And you can use TCP, which says I'm calling, I want an unbroken stream of bits between these two, or you can send datagrams and say I want to send little virtual postcards over UDP. Or you can hybridize like SCTP, but again, it's still mostly just point to point. And IPFS and anything that's using these named data ideas it's a whole different way of looking at it. Now we're saying, here's the data, and let's move it around as necessary. And the more we move it around, now I'm not trying to talk to that machine. Here's what I want, and how do I find that over the network? And there could be more than one source. This is why I bring up flood search routing, is because when you have a very fluid network like the military does, you have a general that might be at the Pentagon in the morning, might be in Iraq in the afternoon, might be in Europe in the evening. Maybe that's a little optimistic. We have some pretty fast planes. But anyway, you can't do phone number-based routing. It just doesn't work because you have to update the tables too frequently. And so they do flood search routing. It just sends out a request that just cascades out over the network.
It's broadcast, sure.
Yeah, who has this person? So you're doing the same thing with data, but unlike, again, trying to do flood search for a circuit connection, now whoever is the closest source of that data, whether it's someone literally sitting next to me who's one hop away, or someone on the other side of the world, you know, it doesn't really matter. It changes the latency. But that's a great thing, is the more you use this. And they go over this. If you look up on IPFS on their webpage, they have a talk at Stanford, and he talks about it in a classroom setting. If you have a lecture, all 300 students, and everyone needs to watch a YouTube video because it's apropos of the lecture, then you're looking at high-def video times 300 simultaneous connections. You're going to just, you know, you're going to have a big pipe to be able to supply that.
You would want to. You want to do a dedicated and then certain, but you would broadcast within your LAN.
Yeah.
But, you know.
And there are, you know, some fancy things you can do on the network. So IPFS says, this is just going to be how it works. So the first guy who grabs some of that can then automatically share that with everyone else. Every time someone grabs the data, they become a source also.
You know, the question, real quick, the joke is you guys have a node like that's terrestrial? Not yet, but you're working on it?
Yeah, Earth. Yeah.
Well, or Pluto or whatever. Very cool stuff. I should look into it because I had not heard of that before. I'm out of networks and do security stuff. But I've been looking at it.
So another element to this, in terms of cryptocurrency, is, and Juan Bennett, who's sort of the originator of IPFS, is looking at how to incorporate a cryptocurrency into this called Filecoin. So, which could be a way to sort of use a currency to throttle the network activity and priorities and stuff like that.
Yeah, that was, if I understand right, I think that was one of the things, there's a couple of things that I've seen recently, because I've been looking at this a lot. So I've heard in the past, you know, one of the problems about email and spamming, and Andreas Antonopoulos talks about all this all the time, is it's free. There's no cost.
Yeah.
And then the thing that I like about the building of Ethereum is that they're building the funding of growing the system and maintaining the system right into the development of the system, if I understood that right. And I heard a talk by this, if I'm saying it right, I thought the guy's name was Vinay Gupta.
Right.
And he talks about that. He talks about the public good and building software systems that, rather than coming up with some initial funding and getting the thing off of the ground and then it fizzles out and there's nobody there to maintain it and keep it growing, you have these systems modeled like what my understanding of Ethereum is, that it generates its own funding for the developers and maintainers and keeps that going through alternative currencies that are built into the software. Do I understand all of that?
Yeah, absolutely. So Ether is a combination of a currency. I would say it's like a security, and it's also kind of a funding mechanism all rolled into one. And it's, like I said at one point, it's in less than a year, their market capitalization has gone from 0 to about $1 billion.
Are you in the wrong business?
No, I think we're exactly in the right business. But what you're talking about, Mike, is this, and I just thought of an analogy. Up until this point, in communications, in networking, in the internet, it's been like we're all sitting around playing poker on a Wednesday night, okay? So I deal cards to Maximum, Mike, and John, Bill, Alia. We're all sitting there, and I got a pretty good hand, but we got no pot. We're not playing, none of us have any skin in the game. And what Ethereum and Bitcoin, and part of what we're talking about here is we're not only mixing communications and data and connectivity, but now we can create these games, basically, where people have skin in it. That's a whole new world.
Yeah, I think so, because that really struck a chord with me when they talked about, just throwing that email out there for free, and all of the troubles that has created, with just getting spammed with everything. If there was a cost, even if it was, what do they call it, micropayments, this micropayment to send a little email, people would really think twice about whether they're going to spam all of these people. I think.
So Ethereum has in it built in this concept of gas, right? I don't want to explain it. Where these transactions, there's a concept, everything that you do also has some idea of the cost associated with it. So that could eventually turn into some real money.
There's gas, which is sort of an immutable monetary measure that can be built into the code. But then the gas is associated with something called Ether, which is like the floating currency.
Okay.
So as they build it, you don't want to have this variability within the code that's subject to market fluctuations, so they created this gas. But then the gas is tied to the Ether that
The actual money
flow with the market. Just to wrap up this point about playing poker, poker's a different game if you got no chips on the table, if you got penny chips, or if you're dealing with $1,000 chips. Yeah, it's a different ballgame.
Now, all that stuff that was just talked about falls under a traditional, like a classical economics model. And I want to point to a counterexample. They're saying, you need something to keep it going. You need to get money involved to keep the system viable. And there's a excellent article here, and there's a lot more written. This is the first one that came up. IEEE Spectrum from 2007. The music industry wants to kill LimeWire. And LimeWire was just the most popular client for the Nutella network protocol. And Nutella uses a lot of the same stuff we're talking about in IPFS, kind of a precursor. And as far as I know, I haven't been on lately, but it's still operational. And the music industry was actually dumping in tens of millions of dollars annually to companies to try to destroy and degrade the Nutella network because they saw it as a threat, and they were not able to. And so you have the exact opposite, where this software got out and got widespread. People started using it and they liked it. And because it was fully distributed, even with concerted effort and huge amounts of funding, they couldn't kill the technology. So I don't think there always has to be a positive economic incentive to make something happen. I think sometimes having the right structure can mean it will happen no matter what, even if there are negative economic incentives, people actively trying to destroy the platform.
Yeah,
I may have lost you there. So
he's just saying, I think to sum it up is, there are different incentives, and money's only part of the incentive.
Yeah.
So if you've got something like what Elio was talking about, there can be other incentives that come into play that can be even more powerful than money.
Yeah.
I wouldn't argue that at all. I think the key in any of this is just to incentivize, you know, and yes, kudos, you're exactly right. Lots of people have lots of different things that motivate them, i.e. incentivize them. And as long as a system provides incentives for people, then the system will stay salient, is my thought.
Yeah, but how they started is that by introducing this concept of gas, where you actually meter the transaction that you have. It may not cost you anything, but having a concept that every time you hit the send button, that there is some kind of metering going on. Just like with your cell phone, if you have an unlimited data, there is metering going on. It's just you don't see the actual dollars per byte until you get to another business model.
Right.
Now,
But at least it's metered.
the other thing, you mentioned email and spam, and that's a huge problem. I think the majority for a while now of email has actually been spam. The amount of legitimate emails is the minority these days. But that's not really because money's not involved, and people have been proposing an email tax for at least a decade or two as a way to combat that, because with paper mail, if I want to spam 1 million people, even if I can get it down to 30 cents an envelope, all said and done, that's still a lot of money. That's still considerable. A large business can foot that bill, but a small, if you're only getting a 1% or less reply rate and you're only getting $2 from it, doesn't work. Whereas spam, I can send out 1 billion spam emails, and even with 0.01% response rate, it costs me so little that if a few suckers reply and I get a few bucks from them, totally worth it. The economics work, which is why it won't go away.
Yeah, the
But
Nigerian
the
model.
problem there is not so much that, there's the economic aspect, but there's also the fact that we do not have good digital identity. Digital identity right now is a freaking joke. It doesn't exist. There's a small handful of people using Web of Trust with GPG, and they have strong digital identity, and everyone else has pretty much nothing, or at least nothing trustworthy.
Is that tying back into the CA thing you were talking about earlier?
Yeah, so that's the opposite of CA. This great quote from Linus Torvalds, and I say this as much as I can because it's really true. People need to know this. But if you've ever done anything in security and it didn't involve the idea of a web of trust, it was masturbation, not security. Because there is no other way. No one has ever proposed a method, a framework for thinking about trust and security that wasn't web of trust. And the CA model was a really stupid, misguided attempt to try to do something. Just, it's that idea, well, something's better than nothing. Not always. And it's been great for the companies that are CAs. They've made an insane amount of money selling ownership of, words, basically. But it's a broken model. It'll never work. Web of trust is the only way. And the problem you run into, the fundamental problem of security, is key distribution. How do you get the keys? How do you establish that link in a trustworthy way? How do you know who you're talking to? And the military solves this with guys with guns carrying around, keys and a memory device. But that's really expensive. That doesn't work well for corporations and individuals.
I've been part of the key exchange. It is Fred Flintstone, no question.
Yeah.
It's still done today.
Yep.
Yeah, that's
So-
the thing with the
So before we've got about another 28 minutes before this is officially over. Does anybody want to look at IPFS on one of these computers and play with it?
I think I want to do some homework on it, but one concept very quickly.
Yeah.
The issue of metering, understood, because bandwidth utilization, that's,
Yeah.
but monetizing that. So I didn't catch that. That's new to me, and I understand charging because, of course, I got bandwidth and, and OC20, OC45, and I'm charging for. But every packet likes spam, but is it self-fulfilling then? So the question is then, could it be then a cryptocurrency? And then since you're part of, let's just say, it almost sounds like a token ring almost, but because everyone's got.
Well,
do you gather the money to help sustain it?
That's part of the experimentation that's going on right now, John. I would say that is part of the innovation that's on the table right now.
A subscription-based network per se.
Not necessarily subscription, but like with the let's take Bitcoin for example. There are fees associated with the mining of each block in the Bitcoin blockchain, and associated with that is also this communicating to the network, because you're communicating to the network, you're spending all this money and electricity to try to crack these puzzles, and if you will. So there's a whole realm of costs and revenues associated with that ecosystem. Same thing, actually to an even larger degree, is being built into Ethereum. And part of what we can experiment with the IPFS is what Juan Bennett, the founder, is talking about. He's trying to figure out the details of this Filecoin, which is also a,
But it's a monetary unit, and so it's generating potential revenue. Maybe that's the wrong terminology, but every packet then percentage you're charged so much for, and so usage based.
There's both revenue potential and there's cost potential.
Certainly. The greater the volume, the larger the costs, and
certainly I think with the Bitcoin ecosystem and the whole Bitcoin model and Ethereum, I think part of what's brought this to the right time is that these are basically games. So, the people that wrote these and are behind the platforms are very much into game theory. And how do you stack the incentives? How do you make the rules so that, the whole ecosystem goes in some sort of direction that, theoretically everybody wants.
Yeah. Well,
so, and with every game, there's a win and there's a loss. And
you're learning, and that's
you're learning, but all I'm trying to articulate is I think we're in a whole new realm where there are all these incentive vectors that are being built into the whole model of communication, of data, of connectivity, and all that stuff. So does that kind of make sense?
It certainly makes sense. There's a whole school of thought at RSA vendors. We're talking about malware, and to defeat malware, machine learning, creating game theory. Mm-hmm. And that game algorithm will learn, and will use Yara as an open source database for malware, and it tests it accordingly, and they're learning from that. Mm-hmm. So therefore, then it's a predictive model. Now, this could all be vaporware. RSA,
you know what I love about that? The saying, complex systems fail in complex ways. And what I love about the security industry right now is everyone wants to throw more cameras and more guards and more complexity at the problem. And the problem is we're trying to guard a house that's made out of rice paper.
Yeah, but
you're not going to be be able to lock it down.
Well, more complexity means more profit. Don't you get it?
Oh yeah, oh yeah.
But
What's the matter with you?
But to build a web of trust, to build a true web of trust is with a small community. That's one thing, but that's a challenge. That's a challenge.
Well, see, like for instance, what I'm planning on doing, hopefully on the next workshop, is to build a simple web of trust model where I just want to turn on a light bulb. And if I use all that IPFS stuff, I should be able to say, this is a reservation for that turning on the light bulb. I walk up to it, I send it a little line of digits, and it would turn on the light bulb. And I just want to add that it's going to cost you 3 Bitcoins to turn it on. Without doing very much, it already is built into the system.
So Internet of Things and Smart House, you could charge for it accordingly. So
exactly, like your cell phone. Yeah. Where it's it's unlimited up until a certain point. Would you like to open up the door, or would you like to get in your house?
There's money to be made.
It's a utopia of nickels and dimes.
Exactly. But I don't have to. The trick is that I can create my own little private kingdom on my own planet and not have it going. But I can then decide, okay, this stuff here, this content, or just this key or this hash. Is this content of maybe the video from my house, and I can sell it to you for this much, and it's already built into the system. I don't have to re-implement. Can you imagine trying to do IoT and have something that's time-based, be able to do money-based? I don't think any of those guys even thought of it yet. in terms
No,
of-
I didn't see any vendor that was talking about that.
Right. But if I build it on top of IPFS like we're doing now, all that comes for free. So the reason that we're putting together, or at least I am, is that it's a fundamentally different way of looking at it, because this is now replacing HTTP as we know it, is replacing BitTorrent as we know it, and it's replacing, the credit card system as we know it. So all of that paradigm completely goes away and replaced by the next web.
Security,
Yeah.
identity as well.
Yeah.
Sure, non-creation.
Yeah.
If you have this, I would love to see it.
Okay.
Yeah,
Well,
we
I'm
can.
gonna let Elio take the wheel.
Can you
So-
record the screen as well?
Now,
Whoever can patch it in somewhere?
now, hopefully we can do that by the day long.
Can you get IPFS, say, on GitHub and things like that? Or
Oh yeah.
it's obvious open source, but I
Yeah. It is. I'm trying to remember. I actually don't have it running right now. But I'll start it up. I'm trying to remember. Is it in Homebrew?
can you push it down to like bare metal switches?
Well, I don't know
It's
about
an
bare
idea.
metal switches, but we
Well,
gotta
this
run
is
on
all-
this.
In theory, you could.
That's all-
I don't
that's
know
all
if
I
anyone's
keep
tried
using,
yet,
right?
but
A lot of Dell's pushing that big time right now. And even Cisco is. And
Mhm.
APIs, they're dominating the network. You don't put configs anymore, you push APIs into it. So you can push SE Linux and all kinds of fun stuff.
yeah.
So you guys want to come over here and
It actually is in Homebrew. So if you're on a Mac, you can do brew install IPFS and you're good to go.
Okay, cool.
So
I'm gonna let you want to show a
This
few
is homework.
simple commands and
And haven't read it and maybe install it.
you know what? We're going to tell it any connection.
And is it two different things that are going, or?
this is the Raspberry Pi 3, and that is you're looking at what's going on the Intel.
And then Alio is going to be communicating to these. Is that what's going to happen?
Alio is actually going to do a séance.
Let's see. Do I still have?
Wireless connection.
Let's see if we can put something in and pull it back out on here. I'm not going to do as in-depth a demo as Christian did. He's done a deeper dive than I have. Do you have the daemon running on here?
I think so. Can you check it? Put the cursor over there. Yeah, there you go. It's been a little while since I played with it. Trying to remember what was the status. Is it just status? Here, I'm gonna do. Did it work? No. Okay, so there's my history for IPFS. So you can do, you have to do an init, and then let's see if we can check the swarm peers. Pretty sure he fired up a daemon on that thing. Okay, so it looks like it's connected to a whole bunch of peers.
Maybe you can just run the
And then,
browser.
yeah, and I'm trying to remember what was their port was that connects on. There's actually a web interface that's really nice,
Yeah.
really
Where's the
interesting.
line?
I'm trying to remember what that was.
So those are all peers within your
They're,
domain?
they're all over the world. And in
They're all
fact,
so I'm only connected.
Are you
to
sharing a
right now.
subnet or it's not routing that way? It's being seen as
it's routing a different
It's
way.
routing just anywhere in the world that you connect to.
There's no subnet.
true broadcast.
And
It goes
it's
like,
And
and then they respond back as far like a hello.
yeah, so that's what IPFS, the main thing is, it's a protocol for talking to all these peers, for managing this list of peers, talking to them, and then handing blocks, chunks of data back and forth.
I will do my homework next time.
So-
I will have read.
and they got a really cool graphic that shows you where all the peers are at
Sure. Like
around the world.
HBO review years ago, and you can dial down, you can see it.
Yeah.
Okay.
And I just
Yeah, so
can't.
you tell IPFS to get a hash of the content of, let's say, a directory. So you get a hash and then it
yeah.
will point to a directory. But
That's
that
it,
hash is
isn't it?
immutable.
Yeah.
So you get that hash.
It
and that's
does
the
take a
content
sec
of
to bootstrap.
that file
So
tree.
the thing with all these, and I don't think IPFS is too different than Freenet, is Freenet project, which is very similar in a lot of ways, but it's much more. So Freenet has the concept of web of trust and of identity built in, even though it's pseudonymous. They don't want you to be able to link any particular person in Freenet back to a real person. That's the whole point. They do all kinds of de-optimizations like random links, data padding, random timeouts, and all this junk, so that it's really hard to link a real person to Freenet. And they also offer a friend-to-friend network, a dark network, where it will only connect to people you've already exchanged crypto keys with. So IPFS isn't like that. It runs, as far as I know, and actually I think Kristen said you can run it that way. It normally runs OpenNet, but I think there may be some provisions that let you run it as friend-to-friend network only. And
Well, see, that's
loading up the computers
that's
here.
part of what we're experimenting with, is adding like white lists and black lists and stuff like that would be really valuable. Another platform that we've experimented with is something called multi-chain that has that permission capability built in. So you can whitelist and blacklist and all that stuff. But we're kind of backing away from multi-chain because they haven't open sourced any of it yet. So,
Some of it, not the important part.
yeah, but
But it's a multi-chain, it's also built.
you gotta go in a putty to, you're just
I was
going
gonna
to
try
browser.
Yeah. I'm impressed that the Edison can run,
IPFS.
well, that plus all this other junk on here at the same time. That
Yeah.
was port 5001, was it? And you can tell I'm not nearly as, haven't been playing with it as much as
It's either port 5001 or 3000.
5001.
Are you trying to bring up a website?
Yeah, it was like a web UI.
Yeah, we had trouble doing that. I don't know. We couldn't do that earlier.
Okay.
Yeah, wait till the Edison runs out of memory. It's really
Yeah.
interesting.
How much memory do they have on?
4 gig. 4 gig of what? Storage, and then a gig of RAM, I think.
But it was 512.
I don't know,
it's a
maybe
gig, yeah.
maybe it's
It's a gig of RAM.
a gig of RAM. And I think you can add an SD card that boosts the storage.
So while he's doing that, I want to make sure that I did. You said that the IPFS is, it's not, so you're gonna seek data. You're not seeking I love what he was talking about, past it's device to device.
Mm-hmm.
And now
Peer-to-peer.
we don't care about device to device, we're after some certain data.
Mm-hmm.
So initially then is the potential that the data is only in one place, but the more, take a video, you upload a video, and initially it's only there, but the more people interested in looking at the video, then the data gets spread out, and then people begin to grab it from the other places. Is that how
that's
it
true.
works?
If you could think of BitTorrent, which only gives you one file, it's one tag. IPFS would say, this is the hash of its content. There could be a tree, you add a Merkle tag on top of it, you can get the versions over time, and you can also get permissions and all the rest of the stuff to go with it. But the simple version of IPFS is that you just get one line of gobbledygook, and it's the actual content. You can then sign up to it and say, yeah, I want a copy of this thing, and it will then be what they call the permanent web, where you get a copy of it, and copies will just propagate.
Okay.
So you come into IPFS saying, I want this, and I'd be able to go look around for it to see if somebody has it, and that's how they would find it. So you would be the root node that has this content. Somebody can say, I want this. They'll grab a content and they'll keep it for them, and then you just keep asking everybody around if they have a copy of it. So
Part of
it'd be kind of like BitTorrent.
Part of
What adds
that-
on top of BitTorrent is the ability to take that hash and use it as immutable, and all of that stuff you add that Merkle tag on top of it.
Tell me what that word immutable you guys have used.
Immutable means that if you take a normal HTTP URL, that's mutable, because you don't know what
You
you're
can
gonna
change
come back.
So it's
So if
changeable
it's
versus
changed or not
unchangeable.
changeable.
If it's immutable, it's unchangeable.
Never
If
change.
it's mutable, you can change it. Does that
So
make sense?
what happens, one of the big problems with the web today is that you keep a URL, there's no guarantee that you're gonna get back what you thought you were gonna get.
Okay.
So-
You could get malware.
Yeah,
Which happens
exactly.
a lot.
So if you use this as a hash of the content, you can make sure that when you get this thing and you can hash your data coming back, that
Looks
you
like it's
you know that
listening.
you either get the right version of the data or not.
Well, that's okay. If you want to just show them some basic
Does
commands.
that make sense?
It does. I know exactly what you're saying.
I was hoping to pull up some things.
Yeah, I know.
Because I put this picture, this is one of my pictures from the local circus arts group. And this is in IPFS, and that's what its URL looks like. So you have that hash. This goes to what Jay's saying with the phone world there. Yeah, so what they've done is, and I really like this, a lot of respect for Juan Bennett and the IPFS team for being forward looking, because this is a problem that's going to bite Git in the butt at some point, although, anyway, there's a whole big discussion about that, whether it matters in Git. Git uses SHA-1, which for cryptographic uses is it's already deprecated. They pulled it out of most browsers.
Yeah,
And they're saying it's a little too easy to attack, and even though there's not too much going on in the wild, that's not going to last for too much longer. So building cryptographic stuff on top of Git is not optimal. So IPFS said, look, hash functions come and go. We invent them, people break them, we invent a new one, they break that one. That's just how it's always gone. No one's ever had, hash functions are too new to have one that's lasted for 50 to 100 years. So we're going to do this thing called multi-hash, and the QN you see at the beginning there is a prefix, kind of like a magic number in a file that, I think it actually turns into like a bit field or some such, but that tells you what kind of hash this is. So in IPFS, you can use MD5s, SHA-1s, SHA-256, RIPE-MD, whatever you want to use, you can throw any type of hash into IPFS, including one we haven't invented yet. So as SHA-256 fails and all these others, it'll be trivial to
It's like a
just
They
swap it out.
built in
Yeah.
future proofing into this platform, which is really tough. Now, one other thing that I'd like to point out.
Pull the picture up just a little bit.
See, so this is a code. This is a hash. If you're not familiar with it, that gobbledygook is a unique string that actually sort of compresses this whole picture. Okay, and if you change one pixel in this thing, it creates an entirely new hash. One pixel.
If the hash function is good, it has the avalanche property, then yeah.
Yeah.
Even
So
one tiny
that is huge.
So you,
Because then it becomes content addressable.
Lossless.
there is no compression.
It's not so much the compression. It's just that there's
The data
There
is
is
not
a
in
unique-
that hash. It's associated.
there's a unique
Points back to
this
So when I get
unique
this data,
code
I can rerun the same algorithm.
ties you
check it.
to that
And I
unique
can say, oh, it's the same.
picture.
Therefore, I got the
Yeah.
data once. It wasn't corrupt.
It's
It
not
was
the verbal
attacked.
tree graph. This is the cryptography in the hash. Basically. But if you change one pixel,
Now it's warming up.
it creates an entirely new code.
I remember I was in the
You see the number of peers.
Navy.
Kind of go block, and now I have
I'm retired
3 or 4 times as much.
That's sending out a protocol broadcast and you're getting
It was
responses back.
probably
I don't know what the discovery mechanism. I wish Chris
So right around
I don't remember what
94, 95, Navy started
somewhere, so
Yeah.
learn how to fish by
teletype tapes and all that to computers.
I have a few little firewalls
And
here, but
sending out
turned off.
message traffic to people's email.
It should be showing
And
little
the big
spikes here.
concern was how do you know that was the original message?
Yeah,
that
this
they
is
were
your
using
little
checksums.
visualization.
Right.
And so, yeah, if
Usually
you
it's little
tampered
blue spikes.
with
Yeah,
the
it's
message,
more-
it would invalidate the checksum. The person would at least know that that's not the original message.
Right.
I have not
So
really
this
paid
is-
attention to the
This has all the properties of the checksum, but it also has this
Checking
secret code, basically.
Now it's a live demo. Check this
Oh,
out. Over here.
No, these things are ongoing group.
Compresses it.
Yeah, so their website
String
is
of something you've never used.
IO.
So
And then they also get,
Um,
now, the other one
another
thing
way
I did,
to think of it is,
So I'm
in order to get into
what I
that
did, I
content,
took all of the,
And it's actually really
you would
nice.
have to
This font
find
is
the exact
excellent.
grain
Yeah.
of sand
long, but
that
it's
each
excellent.
It's on their site.
in all
no, I want to
Exactly.
show you,
in order
what,
to
it's very interesting. I started
access
listing
that.
all of the events that occurred over
So,
the
yeah,
The very
that's
beginning
the way I like to
was
think
this
about it.
thing with,
If I could find that grain of sand
with a guy from the
on all
Internet
beaches
went
of
out this call.
California, then I could get into that picture. But if I don't have that grain of sand,
Yeah.
And so this was in February, and then by October, October, that was when that speech was good.
so
It's like fluid and dynamic.
I'm gonna wrap up the hangout because we're at the end of an hour and a half.
Did I show you this map of all of the events that has occurred? And I have links in every one, so if you
For
want to.
IPFS.
Yeah, so all of the meetups and conventions that occurred.
Cool.
I have a list, so I can get a timeline of all the presentations.
Awesome. Well, I think it's a growing community.
Well, it just shows you how quickly it went, because in what was that? April 15 was this call to replace the web by the Internet Archive founder.
Oh, really?
And that just took off from there, and everybody was answering that from various angles.
Yeah. So the thing that.
Okay, so-
is gonna be important-
So just to summarize tonight, we've solved all. I'm gonna wrap this up. Tonight we've solved all the internet and networking security problems. We've created a new form of money, and we've basically solved a huge computer and device. The IoT issue is definitely solved tonight. So anyway, thank you for tuning in. We're going to stop the broadcast. Join us again on April the 27th when we have the next monthly meetup. And then on April the 30th, we'll have the day-long Desert Blockchain event, which will be a mini conference in the morning and a team hack attack event in the afternoon. So thanks for your interest, and you can go to desertblockchain.com to follow along. Have a good evening.